Hello and welcome to another Cambridge IGCSE paper solving. Today we're going to be taking a look at paper 1 from February-March 2022. Let's get going. So for question number 1, it says a student investigates a pendulum. He measures the time for the pendulum to complete 20 oscillations. He repeats the experiment 3 more times. The readings are shown. What the question is saying is basically find out the average period of the pendulum. A common mistake is to go up, add all these numbers, 17.6, 19.8, 17.6, and 18.6, and then divide them by 4. Well, you're forgetting the fact that it's oscillations per second. So you have to multiply this by the number of oscillations, 20, and if you put that in the calculator, you're going to be left with 17.6 plus 19.8 plus 18.6, 4 times 20 AT, that would be 0.92 seconds. That's the answer for question number 1. Now, let's go ahead and take a look at question number 2. It says, a diagram shows the speed time graph for a moving object. Which statement describes the motion of the object? Now, as you can see, this is a straight linear line, which indicates the fact that this is actually a constant acceleration. If you had a line which was curved like this, that would have been called, accelerating at so basically the acceleration is changing. However, since this is a straight line, then the answer is actually the speed of the object is increasing with constant acceleration, number A. B is definitely wrong. C says it's decreasing with constant deceleration. That's definitely wrong because the line is not does not have a negative slope. And D is also wrong because it's not decreasing or with a deceleration, so these also just rolled out. Let's go ahead and take a look at question number 3. It says, a tennis ball falls from the upstairs window of a house. What can be said about the acceleration of the ball if the air resistance is ignored? So the thing is, any object that is coming down on planet Earth will experience a force of gravity, which is known as weight. So the downward force exerted on any mass is known as weight. You can calculate the weight by multiplying the mass and gravity. However, the speed or the acceleration of the ball in specifics does not depend on the density, does not depend on the mass, and it does not increase as the ball falls. In fact, it is constant and it has a value of approximately 9.8 meters per second square, or sometimes newtons per kilograms. So the answer is actually D. Moving on to number 4, this question says the mass of a full bottle of cooking oil is 1.3 kilograms. When exactly half of the oil has been used, the mass of the bottle plus the remaining oil is 0.9 kilograms. What is the mass of the empty bottle? Now, this question involves a little bit of algebra. This is how I like to go ahead and solve it. I just go ahead and say, in the first part of the question, it's saying that the mass of a full bottle of cooking oil. So the oil plus the mass of the empty bottle, because apparently the bottle has some mass, of course. So if you add the oil to the empty bottle, with the empty bottle, you have 1.3 kilograms initially. However, after half of the oil is used, so basically X, which was the oil, is halved, divided by 2, plus the same amount of the mass of the bottle is equal to apparently 0.9 kilograms. So as you can see, you have 2 simultaneous equations that you can go ahead and solve. The equation is going to be like x plus y is equal to 1.3, and x over 2 plus y is equal to 0.9. You can just solve this by elimination, subtract both equations. You're going to be left with 1 over 2x is equal to 0.4. Thus, the mass of the cooking oil in the first bottle is apparently, or the X is basically just 0.8 kilograms. Now that you find X, you can go ahead and find Y, which is the mass of the empty bottle. So 0.8 plus Y is equal to 1.3. So Y is going to be equal to 1.3 minus 0.8, which is simply 0.5 kilograms. The answer is thus B. Now, a common mistake would be to go ahead and actually half the initial amount of the oil, which is 1.3, divided by 2, you get 0.65 kilograms, right? But you're not considering the fact that there's also a certain amount of mass that exists in the bottle itself. So this would be wrong. Don't do that. Let's move on. Question number 5, it says, a student carries out an experiment to find the density of a rock. Which two quantities does the student need to make to determine the density of the rock? We know that the density of an object depends on two things. Density, which is d, or rho, is simply mass over volume. So which two quantities does the student need to make to determine the density? Well, he needs to find out the actual increase in basically the volume of the rock is not going to be increasing. So actually he needs to find out the increase in the volume of the liquid and the final mass, which is answer number it's talking about the density of the rock. So the actual answer is actually A, the increase in mass and the increase in the volume of the liquid. Moving on to number 6. It says a spring is suspended from a stand, the loads are added, and the extensions of the spring are measured. Which graph shows the result of the plotting extension against load? Well, if you're going to add a load to that spring, what's going to happen is that initially it doesn't have any extension. So it starts from 0. It doesn't start from an extension of like 20 centimeters already, right? So A is rolled out, B is rolled out, the extension is not a constant line, C is rolled out as well. The extension is initially 0, and it starts going up until it reaches the point where, which is known as the limit of proportionality, where the elastic limit will be reached and the spring can no longer go back to its original position. That is known as Hooke's law. The answer is thus D. Moving on to number 7, it says, which are examples of friction? The tension in a spring, the air resistance, and weight. Well, air resistance is definitely a type of friction. Weight is just a type of downward force, so that's not friction. And the tension in a spring is also not necessarily a type of friction. So we can assume that the answer is actually number 2 only, which is C. It says the diagram shows a knot being turned with a spanner by applying a force of F to the spanner. Which equation gives the moment of the force about the center of the knot? Well, we know that moment is always equal to force times by the distance, which in this scenario, the distance would simply be the distance from the point of where the force is applied to the central pivot, which is X. So F times X, that's the answer number A. It says a child pushes a toy along a horizontal surface and then releases it. The car slows down. What is the main energy transfer? Okay, so once the car is slowing down, imagine a car that is moving already. Something that is moving obviously has kinetic energy, right? So this is the toy car. It's moving with velocity, and we know that kinetic energy is equal to half of mv squared. All of this is just irrelevant information. But you need to understand that as the car is moving with a certain amount of velocity and it's slowing down, then its kinetic energy is going to be decreased. What is going to increase? Since this is a straight road, it's not going up or down, the rest of the kinetic energy is actually converted to thermal energy due to the friction between the tires of the car and the ground itself. So from kinetic to thermal, the answer is D. It says, energy resources are used to produce electricity. Which resource is non-renewable? We know that renewable energy resources are the ones that are basically replenished by nature, such as solar energy, but non-renewable ones are things that are not going to be replenished, at least in a very short amount of time, such as oil, coal, etc. So which one is non-renewable? Hydroelectric is definitely renewable. Waves are renewable. Wind is also renewable. The only thing that is not renewable is nuclear fission. This is going to be it for part number 1. Stay tuned for the rest of the questions, the answers to the rest. Hope you find this useful. Good luck.